Though cold and often remote, the icy reaches of the Arctic, Antarctic, and other frozen places affect the lives of everyone on Earth.
Today I want to talk about something that most of you already know. It's hot outside. It's really hot. And if this feels worse than normal, that's because it is. We just found out that July was the warmest month on record. Warmer than any other month since we began keeping track more than a century ago. On top of all this heat, we're also experiencing one of the worst droughts in over 50 years.
Hey, welcome to NASA Launchpad. I'm your host, Vince Whitfield. Clear skies, cloudy skies, contrail skies? People talk about the weather and even the clouds all of the time, but you don't often hear them mention contrails. Actually, contrails are clouds created by people, by planes to be exact. And just like other clouds, contrails may be a very important variable affecting Earth's atmospheric temperature and climate. Contrails represent a human-created increase in high, thin clouds. Now, contrails form when water vapor condenses and freezes around small particles like aerosols that can be found in aircraft exhaust. Some of the water vapor comes from the air around the plane, some is added by the plane's exhaust. Exhaust from an aircraft contains both gas, as in vapor, and solid particles. Both of these are very, very important in the formation of contrails. Contrails are always made of ice particles due to very, very cold temperatures at high altitude. Contrails only form at high altitudes, usually above 8 kilometers or so, where the air is extremely cold, usually less than negative 40 degrees Celsius. Now, contrails were first described around World War I, when aircraft were finally able to reach high enough altitude for this type of cloud formation. At that time, contrails were used by pilots to help them track down other aircraft, sometimes enemy aircraft. See, they could be used to hide from and sneak up on the enemy because they caused occasional visibility problems. And thick, persistent contrails could even lead to aircraft collisions. Today, contrails are studied from a scientific point of view. Let's find out more by talking with Dr. Lynn Chambers, an atmospheric scientist at NASA Langley Research Center.
They haven't been classified in the same way that clouds are, but you can talk about, depending on who you talk to, short-lived contrails, which are the ones that kind of follow along behind the plane and don't ever get any longer. There's persistent contrails, which stick around after the plane goes by. And then there's something we call persistent spreading contrails, which are clouds that form from the passage of an airplane, but then because there's so much moisture available, will actually spread out. And actually today, that's what we have in this area. In our field, we're most interested in the persistent and persistent spreading contrails because those are the ones that are going to have a significant influence on the amount of heat and light that's getting through the atmosphere.
Pretty neat, huh? Contrails may actually move away from the places they were born, blown away by the strong winds at high altitudes, and they can grow large enough to be seen from satellites orbiting the Earth. Take a look at some of these images that show groups of persistent contrails. Wait, so why do we study contrails? Lynn, can you help us out here?
We look at it in the sense of how it impacts the energy budget. So, the amount of cloud cover that's caused by contrails changes the amount of heat that leaves the planet, changes the amount of light that gets to the planet. But the other thing it actually tells you is it tells you a little bit about the amount of humidity up at that level, which is very hard to measure in any other way. So by looking at whether you're getting short-lived, persistent, or persistent spreading contrails, you can actually say something about the moisture content of the air at that layer, which is pretty interesting and useful.
Clouds and contrails are not only studied by scientists, but they're also studied by students, just like you, through programs like SCHOOL and GLOBE. That's SCHOOL, as in Student Cloud Observations Online, and GLOBE, as in Global Learning and Observations to Benefit the Environment. How about that? You could help scientists gather cloud and contrail observations.
We are always looking for people to participate in providing data for us through this project, and there are other projects like this where you can do observations of other natural phenomena such as bird migrations, plants, animals, different kinds of things. So it's always interesting. There's never enough eyes, there's never enough scientists to look at things.
And you thought you had to graduate before you could be a real scientist. For more information on how to get involved, go to www.nasa.gov. Well, that's all I've got for today. I'm Vince Whitfield, so keep your eyes open, look around, pay attention. We'll catch you next time on NASA Launchpad. Cheers.
An ugly effect of fossil fuels. Acid rain. Fossil fuels, oil, coal, and natural gas are running out quickly. And since much of the world's power depends on these resources in the next few hundred years, this could very well be a major problem. However, if we are not more careful about the way we use these natural resources, we won't have to worry about that. The world won't survive that long. The burning of fossil fuels pollute the environment in many ways, including contributing to the greenhouse effect and producing harmful byproducts that are very dangerous to our health. One of these side effects, which causes